I've got some examples here to emphasize this whole, see if you recognize this. I'm going to say compounds, and then over here I'm going to put elements. Spell that right. And we can go back and forth by a chemical reaction. So let me emphasize this. I'm going to go from a compound to an element via some sort of CHM122 chemical reaction. And so like this says, it needs to be some sort of ordinary chemical reaction. We'll talk about chemical reactions later, but ordinary in contrast to some sort of nuclear chemistry reaction. So we have the same atoms we start with are the atoms that we end up with. So what sort of driving force can this chemical reaction be? Well, you're going to see here in a minute we can add heat to make that happen, or we can add electricity to make that happen. So for instance, I have this little video here of mercury 2 oxide. Let's see if it plays. I think it will.
Mercury 2 oxide breaks down or decomposes readily when heated. If we were to weigh the compound before heating and compare its mass to that of the mercury remaining after the reaction, it would seem that decomposition causes a change in the system's mass. The product mercury would weigh less than the reactant. In reality, the decomposition liberates the reactant's oxygen atoms as gaseous dioxygen O2. All matter present before the reaction still exists after it. The reaction obeys the law of conservation of matter.
I love that. So one of the things, do you see those little red particles? Okay, those are oxygen particles. Remember, oxygen is one of the diatomic elements, so you see it actually lifting off as what? O2. Let me see. I bet I can draw on this. Okay, so these right here are O2. Okay, these guys down here are Hg. So what started out as HgO, mercury 2 oxide, now is oxygen and mercury. Okay, so I just think that is so cool. Just kind of and how did it happen? I don't know if you can tell that, but that's heat. All right. Let's see if we can get back to this. Okay. Now this is another reaction. This is actually taking, I'll go ahead and write this for you. This is taking, of course, H2O is water in its liquid state. That's this down here. Here's your liquid water. And it is applying electricity, okay, to make hydrogen gas. Hydrogen's diatomic, so I'll put H2. I'll put a little G there, meaning it's gas, and oxygen gas. Okay, so over here we have, remember we said that the white is hydrogen, and, well, it is here anyway, and the red here is oxygen. Notice that, I don't know if you can see, but we have 2 times this volume is for the hydrogen, and that's kind of cool because we actually end up with twice as much hydrogen as we have oxygen. So I've just kind of balanced it. Okay, so anyway, that is breaking down water to give, water is a compound. I'll put CPD for compound into its elements, hydrogen and oxygen. Pretty cool, pretty cool.